All right, everybody, welcome back to our Unit 1 videos. We've already completed, I believe, 1.1, 1.2, and 1.3. So we're going to go ahead and today and start, we're actually going to skip ahead to topic 1.7. This is our first video on the biogeochemical cycles. Just quickly, kind of going to this next slide here. There's actually four different biogeochemical cycles that we're going to look at. And these are actually topics 1.4, 1.5, 1.6, and 1.7 in Unit 1 for the AP course. So I just like to talk about the water cycle first, even though it's topic 1.7. So we kind of skip the other ones for right now. We will come back to those, obviously. But the water cycle or the hydrologic cycle, I think is kind of the easiest one to learn. So we're going to go ahead and just tackle that one today, kind of get it out of the way. We'll spend a little bit more time on some of the other ones a little bit later on this week. So going back to this term here, biogeochemical cycles, you kind of have like three terms in one. You have bio, right, which is life, geo, which means it comes from the earth, and chemical, which is a chemical process. So all of these cycles contain a biological aspect to them. There's like living things that are involved. They involve the earth in some way, and they involve chemicals in some way or chemical processes. So that's why we call them biogeochemical cycles. So again, we'll start today with the water cycle. And just real quick before I get into the actual diagram and get into the actual cycle itself, just some importances of water, why it's kind of important that we know this cycle and kind of understand like where the water is and what it's doing on our planet. Obviously, it's an important need for living things, right? Cells have to have water, so that's an important thing that we need on our planet. Water vapor or water, just water gas, it's a greenhouse gas, and we talked about that a little bit earlier this year. Greenhouse gases are important for maintaining the Earth's temperature, for making sure that they trap heat to keep our planet warm. Obviously, we don't want too many greenhouse gases up there. We don't want the planet to get too warm, but water vapor is an important greenhouse gas, so warming of the Earth is kind of an important thing. It also weathers rock. We'll talk about this actually a little bit later on when we get into our soil unit. But water, as it moves around on the planet, helps to break down rock, and that's a real important aspect for the formation of soil. So, those are just three things. There's others as well, but, if they ever ask about, why is it important that we need to learn about the water cycle, then, these are three pretty important things. All right, so now for the cycle itself, I'm going to move myself up here a little bit for this one. Okay, so the water cycle, in order to understand it, there is some terminology that we have to know. I think we're kind of familiar with some of these terms, but as I go through this, I'm going to kind of explain the vocab as I go. But the water cycle is all driven by the sun. If we don't have the sun, then we don't have a water cycle. So it's like pretty important because it's what heats the earth. And when water gets warm, on the surface of our planet, obviously it's going to evaporate. So that's kind of where, when the water goes from, the geological, areas of our Earth and up into the atmosphere, that's a process that's called evaporation. So water can evaporate from a couple different places. It can evaporate like directly from, let's say, a lake or a river or an ocean where most of our water is on the planet, right? It's like the biggest reservoir of water is our ocean. It can also evaporate directly from the soil. There's water, there's moisture in the soil, so it can just evaporate directly up from that. It can also evaporate from plants. We have a special name for that. It's called transpiration, but it's just a big fancy word for saying evaporation from plants. When plants photosynthesize, they need water, but there's also some water that's on their leaves and things like that, and then the water just evaporates up into the atmosphere. So make sure we understand these three places from which water can evaporate. It can evaporate from a water source, from plants, or from soil. But again, whatever goes up, obviously can come back down. So when the water is in the atmosphere, it can come back down in the form of precipitation. That could be rain, it could be snow, depending on where you are, right, how cold it is. And when it comes back down to the earth, obviously it can collect on the surface. So a couple things can happen to water once it gets back to the surface. One, it can just run off, into lakes or rivers or streams. That's called surface runoff. It can be taken up by plants. Obviously, plants can absorb it. And the third thing that can happen to it is it can infiltrate into the ground. Right? The term here, infiltration, that just means that the water can kind of seep or percolate through the soil, and it can start accumulating underground. We call that groundwater. Okay, groundwater is a major source of fresh water on our planet. In the United States, we have these things called aquifers. They're underground, and that's where we get a lot of our fresh water from. Okay, we just pull it back up, and we can use it to drink or whatever. So again, all of these terms here, if you understand the terminology, I think it's pretty easy to understand the water cycle. All right, so on this next slide, I've just got all the basic terms for you. I'm not going to go through each one of them with you because I just did in the with the diagram. But again, I would just make sure you go through these, and if you're ever asked to explain the water cycle, these are words that you would be expected to know. I don't think you can explain the water cycle without using the word evaporate, or using the word precipitation or infiltration. I mean, these are words that you have to use when you're explaining it or you're writing about it. So make sure, again, we learn the terminology. That's the quickest way to know if somebody knows it, if they know the terms. All right, last couple things here real quick. How do humans affect the water cycle? Again, this is always something we have to kind of look at. Not only should we understand the cycle, but what's the impact that humans have. We're going to talk a lot about these different things this year, but just kind of introducing you to them right away. One, we just overuse water, right? I mean, there's only so much water on our planet, especially fresh water, and we just tend to overuse it, whether it be for personal use or industry or agriculture. We just overuse water. We have 7.6 billion people, and we are constantly using more and more water. We also divert water. Diversion means we move it from one place to the next. We have a real easy way to do this. Now that we have a lot of technology, we can take a lake or a reservoir of water and we can easily divert it and move it to another location. We can build aqueducts and things like that above ground. We can actually move the water to another place. We pollute it. Obviously, we'll talk a lot about this year. Different chemicals and things that get into the water that will make the water unusable. We reduce infiltration. We just talked about this. So infiltrate means it gets into the soil. Well, I'm going to take a look at this picture on the bottom right here. Right, we've got this giant parking lot that is on top of soil. So when it rains, instead of the water going into the soil, the water just accumulates and puddles on top of the pavement, and it'll just evaporate back up into the atmosphere. So it never really gets into the soil, so that it can accumulate into groundwater. So that's kind of becoming a big problem. We have a lot more of these paved surfaces, parking lots or streets or uh, sidewalks, and they don't allow the water to get where it's supposed to be underground. The last thing, which is kind of an important thing, is deforestation. You would think, well, removing trees, how would that affect the water? But remember transpiration. Transpiration is one of the major ways that water can get back into the atmosphere. So if you remove trees, then you're removing their ability to allow that transpiration to happen. Another thing that trees are really important for is shade. If you've got a bunch of trees, you've got a bunch of shade, which makes it much cooler. If you remove those trees and you remove their ability to provide shade, well, then the soil gets a lot warmer because it's receiving a bunch of direct heat, from the sun, and all of that water that's in the soil can evaporate a lot quicker. So that can affect rates of evaporation tremendously if you cut down trees. All right, we'll stop here with this video. That was kind of a quick one. The next one I'll do is probably on the carbon cycle, the nitrogen cycle, or the phosphorus cycle. Here's your essential knowledge for this particular topic. Make sure we know the hydrologic cycle, which is powered by the sun, is the movement of water in its various solid, liquid, and gaseous phases between sources and sinks. The two sinks would be the earth, the oceans, and also the atmosphere. The oceans are the primary reservoir of water, with ice caps and groundwater acting as smaller reservoirs. Ice caps are something that we'll talk more about down the road as well, but ice caps are frozen fresh water. So when those things are melting, that kind of helps, and that kind of influences the water cycle. All right, guys, that's it for the video for today. Have a good day, and I will see you guys soon.